Do you feel the vibes?
Welcome to Dhivys Techycom. In this video, we are going to derive the condition for distortion-less line. The condition for distortion-less line is given by R divided by L is equal to G divided by C. So this is what the condition we are going to derive through this particular video. So before getting into the derivative part of distortion-less line, we are just about to know the different parameters which are creating a trouble in designing such a distortion-less line. So the first parameter that we are going to consider is alpha, and the second parameter that we are going to consider is beta. So alpha is the major contributor for the distortion called frequency distortion, and beta is the parameter which is the major contributor for phase distortion or the delay distortion. The different types of distortion and the values of alpha and beta which is going to affect the system has been already discussed in the previous video, which is available in our channel. The link has been given in the description. So you can ask me a question, why alpha and beta is considered to be as the major contributors for this distortion? Because there is one parameter called the propagation constant. It is a combination of both alpha and beta, which is given by alpha plus j beta. So that is the reason why when you want to consider the propagation constant, you need to consider this alpha and beta. That is the reason why they are affecting the transmission systems. When there is a distortion in the system, whatever the signal that we transmitted from the transmitter will never reach the receiver. The receiver, when you analyze at the receiver part, will be a totally of a different aspect, different signal. So in order to overcome that difficulties, we want to derive a condition called distortion-less condition. So that is what we are going to discuss now. So you know a condition called alpha, like this is a general equation where we got derived this from the general solution of transmission line. So before getting into the derivative part exactly, I would like to tell you one important point, like it will help you to understand this derivation much better. So the parameter called alpha must be independent of omega. So it should never be a frequency term. Okay, alpha should never be dependent upon this omega term. The main reason why the alpha is increasing the distortion of the system is because it is depending upon the frequency. So you want to make the entire alpha to be independent of frequency. But when you talk about this beta, it should obviously be an independent factor, but here there is a bit relaxation that we people can enjoy, is it can be a linear independent system. Okay, it can be linearly dependent, right? So beta can be linearly dependent on omega, but alpha should never be dependent on omega. It should be entirely independent, but beta can be bit linear dependent of omega. So the next important factor is to get into the condition derivation. So you know what alpha is. It is Rg minus omega square Lc plus square root of the particular term divided by 2. From that, I'm going to take one particular aspect, one important note, which is the term which is here inside the term, right? So this term will be considered and it will be equated to Rg plus omega square Lc. Now let me just write along with the same equations, and we all know what is a minus b the whole square formula and a plus b the whole square formula. So it is a minus b the whole square formula, and here you have a plus b the whole square formula. So now let us just rewrite this entire equation. It is r square g square plus omega 4 alpha square c square minus 2 r g omega square L C. Okay, so then if I'm just expanding this particular equation and I'm also multiplying omega square inside, the first a square term is Lg, right? So when I'm just making it as a square, it is omega square L square G square. Similar way, the next term, it is omega square C square R square plus 2 omega square R L G C. Okay, now on the other part, towards this part, if I'm just equating this particular term, how does it can be represented? It is r square g square plus omega square, omega power 4 L square C square plus 2 omega square R LGC. So now let us just cancel out the unwanted terms, right? So because this R square G square is also here, so let me just cancel it out. Similar way, I have omega 4 L square C square, the same term here, and also I have 2 omega square RLGC, 2 omega square RLGC is also available. So let us just cancel out the terms which is on the same side. So now if I'm just rewriting the entire equation to the next part, it will be looking like this. See, it will be minus 2 RG omega square LC plus omega square L square G square plus omega square C. Yeah, 1 minute. So omega square C square R square is equal to 0. So this is how your equations will be looking like. Now let me rewrite the entire equation. Taking omega square as the common term out, I'm taking L square G square plus C square R square minus 2R L G C is equal to 0. So you know how this omega square, when it is coming to the other part, it will get cancelled. So if I want to rewrite this mid term, I mean the major term here, it will be like LG minus CR or RC the whole square is equal to 0. Right? If I'm taking square root on both sides, it will be LG is equal to R into C. Fine. So you can rewrite the entire equation as L divided by C is equal to R divided by G. So this is one way by which you can write the equation. The other way is either it can be R by L, which is equal to G divided by C. So these are the two different types. You can just rewrite the entire equation, but I request you people to just remember this conditions. To depending upon the given parameters, you can just re-alter. Fine. So LG is equal to RC. One particular term, you keep that in mind so that you can derive the rest of the equations. So this is the condition for a distortion-less line. It is the most important expected questions in any of the HR rounds, or it can be an important 8-mark questions as well. So I request people to please put in more in efforts for learning this particular condition. So I just want to review certain points at this juncture. The main reason for getting into distortionless line is because there are many distortions. The two major distortions are frequency distortion and phase distortion, which is entirely affecting the transmission of signal from one point to the another. So to overcome that, we have to derive a new condition called distortion-less condition. We have derived the equation from alpha term, and we have arrived at LG is equal to RC term. Now it's time to derive the different types of alpha, beta and other parameters in terms of distortionless line. So it is highly important to derive the other parameters associated with the same distortionless line condition. Now let us just take this particular term. Now what I'm going to do is I am going to equate this equation, I mean this part, the upper numerator part, to be like this. Okay, let me write it for you. Square root of RG minus omega square LC plus, instead of that second square root term, I'm just writing as RG plus omega square LC. Okay, the whole term divided by 2, which means the second square root term has been equated instead of RG plus omega square LC as per the first derivative term. So this minus omega square LC and plus omega square LC will get cancelled, and at the last you have 2R G divided by 2. I can just cancel 2 and it will be a square root which is equal to root of RG. Fine. So at last we arrived at the alpha term which is equal to R into G, which is again independent of omega. So the first statement I have told you, the alpha must be independent of omega. So after the derivative part of alpha, we identified it is independent of omega. Fine. Now it's time to derive the beta component. Now let us just again equate this term to Rg plus omega square Lc. The second part here, no, we're just going to equate in the same way what we have did for the previous alpha derivation. Now let us just put it into omega square Lc minus Rg plus Rg plus omega square Lc whole value divided by 2. So what are the terms that has to be derived? To be cancelled out, it is r minus rgn plus rg. So what are the other terms you have? It is 2 omega square LC divided by 2, and this 2 will get cancelled, and the rest of the terms it will be omega square LC. Again you will have a square root. If I'm taking omega out of the square root, it will be omega and in the root of LC. So final equation of beta will be linearly dependent upon omega. So this is the final equations of beta. So alpha should be perfectly independent of frequency, whereas beta can be linearly dependent upon frequency. So that is the second important parameter. Now let us just derive the most important parameter called as the propagation constant, which is equal to alpha plus j beta. So what is the alpha value that we have derived? It is equal to r into g plus j. What is the value of beta? Omega root of LC. So this is how your final equation looks like. And also there is a general equation which I would like to share with you people, which is a very, very general term. R plus j omega L into G plus j omega C. Okay, you can just have this for your reference, but this is what the exact equation for gamma. Fine. Now it's time to derive the velocity term. We know how velocity is represented as it is omega divided by beta. Okay, so we know what is beta value. We have derived it in the previous slides, omega into root LC. So now let us just cancel the same terms, omega at the numerator and denominator part, and you'll have 1 divided by root of LC. So this is the velocity in terms of distortion-less condition. And now we are going to calculate Z0. Z0 is nothing but the characteristic impedance. So Z0 is equal to root of Z divided by Y, which is equal to root of R plus j omega L divided by G plus j omega C. Now let me just rewrite this equation. Root of, let me take L as the common term out, and I'll take R divided by L plus j omega. In the denominator part you'll have, let me take C out, right, which means I'm taking the term at the last part of the equation, divided by j omega. Okay, let me just consider like this. So as per the distortion-less line, R, L and GC are R divided by L is equal to G divided by C. So let me just cancel out two terms. At last I'll be getting L divided by C. Okay, so these are the most important parameters which I request you people to please keep in mind when you're deriving the distortion-less condition. So what we have discussed so far, we have analyzed how alpha should be in terms of distortion-less line, and then beta we have derived, where beta can be linearly dependent on omega. Then we have derived a propagation constant, velocity and the characteristic impedance. This is the most expected question, and there are many problems that has to be derived with distortion-less condition that we'll be discussing it in the next video. I hope this video was informative enough to you people. For further updates, stay tuned with Dhivys Techycom. Thank you.